Welcome to Unkosh, where academics is made easy. 10th board exams, and we have to study entire book of chemistry. How about we study the chapter that carries the most marks first? The first chapter that we are starting with is organic chemistry. Don't worry if this is not your first chapter that you're studying. Either which ways, I'm sure you're going to fall in love with organic chemistry. Let's get started. Now, before we dive deep into carbon, its compounds, and organic chemistry in general, first let us start with a simple topic called substances. Now, substances, whatever that we see around us, are things and they are made up of small particles which we can call as substances. And these substances are broadly classified into two categories, organic and inorganic. Why do we categorize them this way? It is because of the sources from which these substances are derived. Organic substances are derived either from a plant source or an animal source. And inorganic substances exist in nature, specifically speaking about Earth. They are existing materials on Earth which are utilized by animals and plants to create more and more organic substances. Once we are clear about the topic of substances, now let us understand this separate branch of chemistry that we have defined as organic chemistry. It is the chemistry of specific carbon compounds. Now, most of the organic substances that we are going to talk about are going to be of carbon. So, we need to understand that specific carbon compounds create this unique set or group of chemistry field called organic chemistry. And carbon is not just the main element here. Another important element is hydrogen. So there are lots and lots of carbon and hydrogen bonds that we are going to see in this chapter. And these compounds which are made up of hydrogen and carbon are called as hydrocarbons. So hydrocarbons are nothing but organic compounds. Of course, they are organic compounds composed of carbon and hydrogen. So there are going to be carbon hydrogen bonds that we are going to talk about in the upcoming slides. But before getting into that topic, let us first understand a little bit about inorganic substances as well. So most of the carbon compounds are grouped under organic chemistry. However, there are certain carbon compounds which are not organic. So they would be inorganic in nature, right? And these inorganic carbon compounds are mainly oxides. Now, oxides are something that you can find in rusted iron. Carbonates. Carbonates are something that you can find in chalk, in toothpaste, and carbides. Carbides are something that you find in drill bits or in any carpentry tools wherein drilling or cutting is required. So these carbon compounds are inorganic in nature, whereas most of the carbon compounds are organic in nature. And because we are talking so much about carbon, let us first understand our hero element in this organic chemistry world, which is carbon. So we are only going to talk about specifically carbon right now. Here, carbon is an element, of course, we know about it, but what is the nature of carbon atom that helps it produce so many organic compounds? Let us understand those natures or properties of carbon atom. So whenever we are talking about nature or property of carbon atom, we need to understand that there are four nature or property pointers, which are tetra valency, catenation, isomerism, and how carbon can form covalent bonds. Now we are going to understand each terminology one after the other. You don't have to get puzzled with all these new terminologies. I'm sure some of them you can figure out on your own. Like, for example, you must have heard of the word tetra. If not, let me remind you, it is nothing but four. Okay, tetra means simply four. Now, valency is something that you have already studied in your previous class, wherein you have learned the definition that it is nothing but the number of electrons gained, lost, or shared by an atom of an element to attain stable electronic configuration, right? So what is this stable electronic configuration? We have heard of this terminology also in previous class. If you're not able to remember for some reason all these concepts from ninth standard, don't worry, we have it covered for you. You can check the description down below and find the link to revise your previous year's topics. Let's continue, assuming that you remember these terminologies. Now, carbon is showing tetravalency. It means it has got 4 electrons as valence electrons in its outermost shell, right? So there are 4 electrons. Carbon is totally having 6 electrons, right? The first 2 electrons will be placed in the K shell, and the next 4 electrons will be placed in the L shell. We have seen distribution of electrons around carbon nucleus in previous class, right? So here we know that there are 4 electrons in the outermost shell, and they will require 4 more electrons to attain a stable electronic configuration. So here carbon is going to share its 4 electrons with other atoms and its electrons, so that it will form a covalent bond. Whenever electrons are getting shared, we know that it is a covalent bond. So here electrons are going to form covalent bond to attain stable electronic configuration. In a way, we can say that there are 4 electrons hunting down 4 more electrons from its surroundings to gain stable electronic configuration. That's why we know that carbon is showcasing the property of tetravalency. Now, next nature or the property that we are going to talk about is catenation. What is catenation? It is nothing but the property of elements wherein atoms of element can link to each other in the form of chains of identical atoms. Now, identical atoms, since we are talking about carbon, the identical atoms are going to be carbon. So, if there are carbon atoms lying around, they have a tendency to link to one another more compared to linking with other elements which are present around. Okay, so carbon has got this tendency to link with other carbon atoms in its surroundings, and that's why it is showcasing the property of catenation. Now, this linking is really important. Why? Because catenation is maximum in carbon. Okay, we need to remember that catenation is maximum in carbon, and the value of carbon carbon bond energy is maximum. Okay, why? Because when two carbon atoms come together, while forming that bond, they have maximum amount of energy. That's why we say that catenation is maximum in carbon, and carbon undergoes self linking, so catenation is prominent. Now, when carbon is undergoing that self linking, what is happening is carbon ends up forming chains. Okay, see, one carbon is getting attached to the other one is getting linked to the third one. So, here we end up seeing chains. Different kinds of chains will be seen, right? There could be chains. See, now this carbon, since it has got 4 valent electrons, it is attached to 2 carbons. It could further attach to another carbon here and here. Here, different forms of chains can be seen. So, which are those forms of chains that carbon can form? It can either form a straight chain, which we saw just now, wherein there is a straight line, a single line in which carbon is getting linked. It could form branched chains, which we also saw, wherein this was the straight line, but this carbon has got a branched chain as well. Or it could form closed chains. Now, what are closed chains? They are nothing but ring structures wherein carbon is forming a ring. There is no open end to it. We are going to see this more in detail. Just remember for now that the chains that carbon can form could be either open chains wherein there are two open ends to the chain, or it could be a closed chain wherein there is no open end to the chain that it is forming. Okay. Other than that, we have another property of carbon, which is isomerism. Now, what is this new term isomerism? It is nothing but when a compound is having same molecular formula but a different structural formula. Is it possible that a compound could have same molecular formula but a different structural formula? When it comes to carbon, it is definitely possible. Let's see how. Suppose, for example, we have four carbon compound. Okay, it is a chain. Four carbons are linked to one another. Now, how could they be linked? One, two, three, four. It is possible that all four of them are linked this way. Remember the open chain, open ends, right? This is a straight chain formation. Or else the same four carbon atoms could also be linked in this manner, wherein three carbon atoms got linked to one another in an open chain, straight chain, but the fourth carbon atom got linked to the carbon atom in the middle. Here also there is 1, 2, 3, 4 carbon atoms. Here also there are 4 carbon atoms. Yet they have different structures. We can see that they appear different. When we look at the compound, the structure of that compound is different. But if you see the molecular formula, it will be same number of carbon atoms in both of them. Here we can call these two compounds as isomers of each other. Why isomers? Because they have same molecular formula but different structural formula. We'll be talking a little bit more in detail on isomerism and all its examples, how these carbons are forming chains, a little later in the video. Let us move on to the fourth property of carbon, which is formation of covalent bonds. Now, in previous classes, you have studied about what are the types of bonds, chemical bonds, right? The two of them, which were the main chemical bonds, were covalent bonds and electrovalent bonds. And electrovalent bonds are also called as ionic bonds. Remember this? If you don't, then definitely I would recommend you to visit the revision chapters from the link down below in the description, so that you get to revise those 9 standard topics and then you can continue with this chapter. Okay, so assuming that you remember the types of chemical bonds that we had studied in previous class, which were 3 in number, but right now we just need to remember the two main chemical bonds, which are covalent bonds and electrovalent bonds. Here, covalent bonds is something that we can see in organic compounds. Organic compounds form covalent bonds, whereas electrovalent bonds are formed by inorganic compounds. Okay, so carbon is having its nature of formation of covalent bonds. That's why organic compounds will be seen forming covalent bonds. So whenever you have to answer this question, why do we need a separate branch of organic chemistry? What is so special about carbon atom? What is the nature of carbon atom? What are the properties of carbon atom? All these questions lead to only one answer, which is a 4-pointer answer. Because carbon is showcasing tetravalency, because carbon is showcasing catenation, isomerism, and it forms covalent bonds. Now that we have understood about carbon specifically, let us understand the carbon compounds, organic compounds that we are talking about. So far, we have understood that substances are classified as organic or inorganic, and because we have so many specific, unique carbon compounds under organic substances, that's why we have a separate branch of organic chemistry. Okay, so now let us understand the properties of organic compounds. Previously, we were talking about properties of carbon atom, only carbon. Now we are going to talk about properties of organic compounds in general. Okay, as a whole, these compounds are exhibiting certain properties. What are those? First of all, when I say organic compounds, of course it has got carbon in it, but other than carbon, which are those elements that are playing a role to form organic compounds. Let us talk about the composition of organic compounds. Now, composition is nothing but which all elements are involved in formation of organic compounds. They are carbon, because we know that organic compounds are hydrocarbons, so of course hydrogen. Other than that, you need to remember that there is nitrogen involved, oxygen, phosphorus, sulfur, and also we have got bromine, iodine, chlorine, and fluorine. So these are the elements which are involved in formation of organic compounds. Okay. Other than that, we need to remember that organic compounds have got very low melting points and boiling points. Now, are they extremely low? No. When I say they have got low melting points and boiling points, this is in comparison to inorganic compounds. When if we are to boil, say, leaf. Now leaf is made up of organic compounds. We know leaves are plants parts and plant is organic, so we are taking leaves as organic compound example. A common general example, suppose if we are boiling a pot of leaves. Now what is going to happen is, if you see, these leaves will start getting hot and lose its solid structure and turn into a gooey liquid, greenish liquid, easily at very low temperatures which are found in the kitchen. Whereas if you take a rod of metal, okay, and try to boil it, can you start melting it in kitchen? No, you won't be able to. You need very high temperatures, direct fire, in which you are trying to burn and burn it, yet it only melts to a point wherein maybe you are able to twist it a little bit, but it won't melt into a liquid state completely at such temperatures. To convert inorganic substances from one state to the other, you'll require so very high amounts of fire and closed ideal conditions that they are very difficult to achieve. So in comparison to inorganic substances, organic compounds have got low melting point and boiling point. And of course, if someone asks what are the properties of inorganic compounds, they have got high melting points and boiling points. Okay. Other than that, what about solubility? Are organic compounds soluble in water? No. Again, we have the same example wherein we are trying to boil leaves in a pot of water. What happens is, we observe that the leaves are getting melted due to heat into a gooey green substance, but they are not easily soluble in water. If you don't believe me, try it at home and do let me know if whether the leaves got dissolved in water or not in the comments down below. So for now, I guarantee you that they are insoluble in water. But if you have an organic solvent in hand, which is not easily available at home in the kitchen, so we are going to perform certain experiments in upcoming videos. You can keep an eye on that to understand what are organic solvents. But for now, you need to remember that organic compounds are easily dissolving, are easily soluble in organic solvents, but not soluble in water. Inorganic compounds, on the other hand, may be soluble in water. Okay. What about volatility? Organic compounds are volatile in nature. They are combustible in nature. They can easily catch fire. Now, what about nature of compounds? Because these organic compounds are made up of carbon, and carbon forms covalent bonds. So, nature of organic compounds is also forming covalent bonds. Okay. What about conduction of electricity? Organic compounds are bad conductors of electricity. Inorganic compounds are good conductors, but organic compounds are bad conductors of electricity. And of course, we have this answer which is from carbon, once again repeated here, because organic compounds are mainly made up of carbon. So the nature of carbon is also the nature of organic compounds. So organic compounds exhibit catenation property, exhibit isomerism, and that is going to be common with carbon. Next, let's move on to understanding organic compounds more in detail. Previously, we had talked about how organic compounds are can be categorized as animal sourced or plant sourced, but that is a very general category. There are so many organic compounds which are present in both of them, so that cannot be like a very strict rule that there are two types of organic compounds which are plants and animals. No, because of that we need to understand the actual classification of organic compounds, wherein we can classify them on the basis of the chains that they are forming. Previously, we had talked about the chains, remember? So, here we are going to say that organic compounds are of two types, which are aliphatic organic compounds and cyclic organic compounds. Now, cyclic organic compounds sometimes are also referred to as aromatic because most of the aromatic compounds are cyclic. Okay, so here we need to remember that they are not, all of them are not aromatic, but most of them are. That's why sometimes cyclic organic compounds are also referred to as aromatic. For now, we are going to call them cyclic organic compounds. Now, cyclic we know are having the tendency to form closed chains. So, close chained hydrocarbons will be called as cyclic organic compounds, and they are of two types. Now, homocyclic, homo meaning same, or heterocyclic, hetero meaning different. So, when within a cycle, within a ring, there are same there are atoms of same element, like for example we know we are talking about carbon. So when the entire ring or the cycle closed chain is having only carbon atoms, then it will be called as homocyclic carbon compound, whereas heterocyclic organic compounds have a ring in which instead of carbon there could be other elements as well. So it's not just about carbon. So heterocyclic organic compounds would be having more than one element within the ring. Now you don't have to worry about all the its structures and examples because that is not a part of syllabus in detail. For now, you just need to remember this within the syllabus, that there are two types of organic compounds which are aliphatic and cyclic are nothing but closed chain organic compounds which are of two types, homocyclic and heterocyclic. Other than that, detailed examples are not a part of your syllabus. What we are going to study in detail is aliphatic organic compounds. So let's move to aliphatic organic compounds, which are going to be open chained, which are going to be having carbons with ends to it, whereas the cyclic ones were having no end. Okay, they were ring structures. Whereas now we are going to talk about open chained organic compounds, which are aliphatic hydrocarbons. Okay, aliphatic hydrocarbons are of two types, saturated or unsaturated. Now, what are these terms, saturated, unsaturated? We are going to understand in detail a little later. For now, just remember that aliphatic hydrocarbons are of two types, saturated and unsaturated. And now, saturated hydrocarbons, or you can say saturated aliphatic organic compounds, are alkanes. Okay, there are only one type of saturated organic compounds which are alkanes, but unsaturated organic compounds are two, which are alkenes and alkynes. Okay, see, look at the difference. They all look similar, but there is one A in it, there is an E in it, and there is a Y in it. Okay, so alkanes, alkenes, and alkynes. They are also having other names to them, which are of different nomenclature, common naming system. But IUPAC naming system, which we are going to study in the upcoming slides, will have these terminologies: alkanes, alkenes, and alkynes. So, aliphatic organic compounds are two types, saturated and unsaturated. What is saturated? What is unsaturated? We are going to talk about it now. And saturated aliphatic organic compounds are alkanes, unsaturated ones are alkenes and alkynes. Now, let us understand in detail about alkanes. Okay, let us start with the saturated carbon compounds. Here, why we are saying saturated? Let's take an example. of, say for example, we are talking about propane. Okay, now what is propane? Propane is nothing but a 3 carbon compound. So a carbon compound, an organic compound wherein there are 3 carbon atoms, and because they are showcasing the property of catenation, we say that they are forming chemical bonds with each other which are covalent in nature. So we have got carbon carbon link. However, we also know that carbon atom as an individual is tetravalent in nature. So this every carbon is going to need to form 4 bonds with some or the other atom around it. Because it is forming one bond with the second carbon, what about the rest of the 3 bonds? It is going to form those bonds with hydrogen. Okay, so here, because we are talking about example of propane, let me say that this carbon which is forming 3 bonds with hydrogen and 1 bond with carbon, let us complete the entire bond formation. Okay, here 1 2, what about the 3 and 4? Of course hydrogen. Here 1, what about 2 3 and 4? Hydrogen. So we have 3 carbons which are linked to one another, and the remaining covalent bonds are formed with hydrogens around them. Okay, so here we have completed the structure of propane. Here we can see that a single bond is formed between 2 carbon atoms. Instead of this single bond, if there were more than one bonds formed with the same carbon atom, then they would have been called as unsaturated aliphatic hydrocarbons. Here, because there are all the carbon carbon bonds are single, that's why they are saturated. No further breaking down is required, no further saturation is required. This is the most saturated form of carbon carbon linking. That's why they are saturated aliphatic hydrocarbons. Now I hope that the concept of saturated aliphatic hydrocarbons is very much clear. If not, then you can check the description down below and visit the link to the video wherein I have covered the topic of alkanes in detail. Okay, so let's continue. Here, because we have understood that they are saturated, they are going to contain carbon carbon single bond. Every carbon, 2 carbons are going to have single bond between the two of them, and they are also known as paraffins. This is a common naming system wherein they were named after some or the other sources or some or the other discoveries. Here, why it is called as paraffin is something that you need to find out. It is a very interesting fact. If you want to know further why they are called as paraffins, check shorts on my channel and you'll come to know why alkanes are called as paraffins. Next, we know that there are unsaturated hydrocarbons. Out of the two, there was one called alkenes, which has got E. Okay, so alkenes are nothing but unsaturated aliphatic hydrocarbons. Now, because we talked about saturated, wherein there were carbon-carbon single bond that I was repeating, here definitely they are not going to be single. But are all the carbon-carbon bonds not going to be single? That is not the case. Let me just take one by one what they are going to be. So they are going to contain one, okay, I repeat, one carbon carbon double bond. Okay, let's take that same example of 3 carbon wherein we were talking about propane. Now we'll talk about propene. Okay, how the spelling is changing, what the naming system is, we'll be talking about it in detail a little later in this video. But for now, just remember, alkene example is propene, wherein we have got 3 carbon atoms. Again, 3 within the compound. We need to have carbon carbon bond, catenation property, but since it is an alkene, it has got one carbon carbon double bond. So anyone like these 2 carbon atoms, for example, we can show double bond. Okay, so rest of the carbon carbon atoms will have single bond only, all of them won't have double. Okay, always remember, one carbon carbon double bond forms alkenes. So whatever the example is, however many the carbon atoms are within the compound, we will always have one carbon carbon double bond, and rest of them will have carbon carbon single bond. Then that compound will be called as alkene. Okay, and they are also known as olefins. Why olefins? Now that is something that you're going to find out, and let me know in the comments down below. If you want to know the interesting facts behind this naming system, then do visit the shorts. The third type was unsaturated again, but it had got a different spelling, which was Y. Here it is also unsaturated, but it is having one carbon carbon triple bond. Now we are taking the same example again, wherein there are three carbon atoms within the compound, and it is going to be called, because it has got three carbon atoms and we are going to talk about the triple bond, it is going to be called as propyne. Okay, so here it is going to have one carbon carbon triple bond, and rest of them are going to be single bonds. Okay, and they are also known as acetylenes. Now let us understand why they are called unsaturated. Now what is this unsaturated thing? Here what happens is they are not as saturated, they are not as saturated as alkanes. Why? Because carbon carbon triple bond is easier to break compared to carbon carbon single bond. So when we have a carbon carbon triple bond, it will be broken down comparatively easily and can be saturated further into alkenes, wherein carbon carbon double bond will be remaining. On further saturation, what happens is, on further breaking down of that carbon carbon double bond, carbon carbon single bond is remaining. So that way, once the alkyne can be easily converted to alkenes can be comparatively easily converted to alkanes, but further there is no more carbon carbon bond left to be broken. At least minimum one carbon carbon bond when remains, it is having maximum energy. Remember we had talked about it, carbon carbon bond will have maximum energy. So now this is not easy to break, so this is the saturated form, whereas unsaturated forms are the ones wherein there is still scope of breaking at least one bond further. Okay, that's why we have got this saturated and unsaturated difference. So we have already covered about organic compounds being aliphatic and cyclic. Aliphatic is nothing but open-chained hydrocarbons which are saturated and unsaturated, right? Saturated are alkanes which are single bond carbon links. Unsaturated are alkenes and alkynes. Alkenes are having one carbon carbon double bond. Alkynes are having one carbon carbon triple bond. And what are they also called? Paraffins, olefins, and acetylenes. Click the link down below and watch the next video of this series. To complete the chapter, click on the playlist and watch the entire series. See you in next class.